Is our sun hiding a dark secret? A companion star, a Death Star, lurking at the edge of our solar system, periodically unleashing waves of destruction upon Earth. This is the core of the Nemesis Hypothesis, one of the most captivating and controversial ideas in modern astronomy. It is a theory that attempts to explain a terrifying pattern in our planet's history, a cycle of mass extinctions that seems to repeat with eerie regularity. Could there really be a second star in our system, a bringer of doom we've yet to find? Let's journey to the farthest reaches of our cosmic neighborhood and investigate the mystery of the sun's long-lost twin. The story of Nemesis begins not in space, but deep within Earth's geological records. In the early 1980s, paleontologists David Ropp and Jack Sepkowski were studying the fossil record and made a startling discovery. They found that mass extinctions, events that wipe out a significant portion of life on Earth, don't seem to happen randomly. Instead, they appear to occur in a cycle, roughly every 26 million years. This periodicity was too regular to be a mere coincidence. It suggested some kind of cosmic clock was ticking, with each tick spelling disaster for life on our planet. But what could possibly cause such a regular, long-term cycle of devastation? This is where the astronomers stepped in. Richard Muller, Walter Alvarez, and Mark Davis proposed a bold and frankly terrifying explanation. They suggested that our sun isn't alone. Far, far away, orbiting at a distance of about 1.5 light-years, is a dim, unseen companion star. They named it Nemesis, after the Greek goddess of retribution. According to the theory, Nemesis is likely a red dwarf or a brown dwarf stars that are much smaller and fainter than our sun, making them incredibly difficult to detect. So, how does this distant, dim star cause extinctions on Earth? The answer lies in its orbit. Nemesis follows a huge, highly elliptical path around the sun. For most of its 26 million-year orbit, it's a quiet, distant neighbor. But once every cycle, at its closest approach, its gravitational pull wreaks havoc on the outer fringes of our solar system. Specifically, it disturbs the Oort Cloud. The Oort Cloud is a theoretical, immense spherical shell of icy bodies, like comets, that surrounds our solar system. Think of it as a giant, cosmic beehive. When Nemesis passes by, its gravity is like a stick poking that hive. It jostles billions of comets from their stable orbits, sending a deadly shower of them hurtling toward the inner solar system. With millions of comets suddenly on a collision course, it becomes a game of cosmic roulette. It's inevitable that some of these comets would cross Earth's path. A large enough impact would be catastrophic. The initial explosion would be devastating, but the long-term effects would be even worse. A major impact would throw massive amounts of dust and debris into the atmosphere, blocking out sunlight for years, a phenomenon known as an impact winter. This would cause global temperatures to plummet, plants to die off, and the entire food chain to collapse. This scenario perfectly matches the evidence we see in the geological record for mass extinctions. The most famous of these events is, of course, the extinction of the dinosaurs. About 66 million years ago, the Cretaceous-Paleogene extinction event wiped out roughly 75% of all species on Earth. We have strong evidence that this was caused by a massive asteroid or comet impact, which left behind the Chicxulub crater in modern-day Mexico. Now, let's look at the timeline. 66 million years ago. If the extinction cycle is 26 million years, that fits remarkably well. Could the dinosaur killer have been a comet, nudged from the Oort Cloud by Nemesis on one of its fateful flybys? The Nemesis Hypothesis suggests exactly that. It provides a grand, unified theory that connects the dots between a regular extinction cycle, the Oort Cloud, and the very event that ended the reign of the dinosaurs, paving the way for mammals, and eventually us, to rise. The idea of a celestial Death Star is incredibly compelling, but is it true? The scientific community immediately split into two camps. On one side were the proponents, who argued that the statistical evidence for the 26 million-year cycle was strong and that Nemesis was the most elegant explanation. On the other side were the skeptics, who questioned the data and the very stability of such an orbit. The hunt for Nemesis began in earnest. Astronomers knew what they were looking for, a faint, cool object with a high parallax, meaning its apparent position in the sky would shift more than distant stars as the Earth orbits the Sun. This would be the telltale sign of a relatively nearby object. Various sky surveys were launched, using powerful telescopes to scan the heavens for our Sun's elusive companion. The Infrared Astronomical Satellite, or IRAs, conducted a full sky survey in the 1980s, but found no candidates. Later, the 2MASS survey did the same with even greater sensitivity. Still nothing. The biggest blow to the theory, however, came from the Wide Field Infrared Survey Explorer, or WISE, a NASA space telescope launched in 2009. WISE was the ultimate nemesis. It was so sensitive to infrared light that it could have detected a brown dwarf like Nemesis out to a distance of 10 light-years. In 2014, after years of scanning the entire sky, the WISE team announced their results. They had found no evidence of a large companion star or gas giant in the outer solar system. The search for Nemesis, at least in the form originally proposed, came up empty. Furthermore, other scientists began to re-examine the evidence for the 26 million year extinction cycle itself. Some argued that the cycle was just a statistical illusion, a result of small sample sizes and dating uncertainties in the fossil record. They pointed out that while some craters on Earth seemed to align with the cycle, many others did not. The neat, tidy pattern that Ropp and Sipkowski had first identified began to look a lot messier upon closer inspection. Other mechanisms have also been proposed to explain periodic comet showers, such as the solar system passing through the dense plane of the Milky Way galaxy, which could also gravitationally disturb the Oort cloud. This galactic plane model offers an alternative cosmic clock, without the need for a companion star. So, where does that leave us? Is the Nemesis hypothesis dead? Not entirely. While the original idea of a star in a stable 26 million year orbit has been largely ruled out, some scientists hold out hope. They argue that Nemesis could be smaller and dimmer than we thought, or that its orbit might have changed over time, making it harder to find. Perhaps it wasn't a star that caused the disruption, but a primordial black hole, which would be even more difficult to detect. The mystery of the periodic extinctions remains, and while the evidence for a Death Star has faded, the question of what caused these catastrophic events is as compelling as ever. Today, the Nemesis theory is more of a fascinating what-if than a leading scientific hypothesis. It's a testament to the creativity of science, a bold idea that spurred decades of research and pushed our technology to its limits. The search for Nemesis forced us to map our cosmic neighborhood in unprecedented detail, leading to the discovery of thousands of brown dwarfs and other celestial objects, even if our sun's evil twin wasn't among them. It serves as a powerful reminder that our place in the universe can be precarious. Whether the threat comes from a hidden companion star, a journey through the galactic plane, or a random rogue asteroid, the cosmos is a dynamic and sometimes violent place. The story of the Death Star is a perfect example of the scientific process in action. A mysterious pattern is observed, a bold hypothesis is proposed, and a rigorous search is undertaken to test it. Even though we never found Nemesis, the quest itself expanded our understanding of the universe. It remains a cosmic ghost story, a captivating tale of a hidden enemy in the dark. While it may not be real, it sparked our imagination and drove us to look deeper into the night sky, forever changing our view of the solar system we call home. What do you think? Could something still be lurking out there? Let me know in the comments. Thanks for watching, and if you enjoyed this journey into cosmic mysteries, don't forget to like, subscribe, and hit that notification bell for more. See you next time.